Okay, so now we're going to introduce the Lagrange polynomials. So Lagrange polynomials is defined to be this formula. So you see, this is a product of x minus xk, and k run from 0 to n but has the difference from j. And it divided by xj minus xk, and here k has the difference from j, k run from 0 to n. So this is a general formula. Now suppose we have a data. So the data as before, so you have 4 points, okay? And now based on those 4 points, we're going to construct the Lagrange polynomials. So Lagrange polynomials are introduced to compute the interpolation polynomials without solving a linear system, okay? But the first step is we have to write the Lagrange polynomials first, and now use the formula. So now suppose, so this one is my x0, yeah? And x1, so x0 is 0, x1 is 1, x2 is 2, and x3 is 3. Then I will write out L0, so L0x will be a product of x minus everything except x0. So x minus 1 times x minus 2 times x minus 3, yeah? And then, so that is x minus xk, but k different from j. So j equals 0, yeah? So k run from 0 to 3 and has the difference from 0. And then in the bottom, then you put in x0, so x0 will be 0, minus 1, 0 minus 2, 0 minus 3. And then this one gives you minus 1 over 6. Combine those 3 numbers, x minus 1, x minus 2, x minus 3, okay? And similarly, you can construct L1, so L1x will equal x minus everything except x1. So x minus 0, x minus 2, then x minus 3. And then you put in x1 in the bottom, so you put in 1 minus 0, 1 minus 2, then 1 minus 3. And this one gives you, so 1 here, so this one is minus 1, this one minus 2, so 1 over 2, x times x minus 2, x minus 3, okay? And similarly, you have L2 will be x minus everything except x2, so x minus 0, x minus 1, x minus 3. And you have to put in x2 in, so 2 minus 0, 2 minus 1, 2 minus 3. And this one gives you 2, this one gives you 1 minus 1, so minus 1 half, x minus 1, x minus 3. And the last one is L3 will be x minus everything except x3, so x minus 0, x minus 1, x minus 2. And then you put in x3 will be 3 minus 0, 3 minus 1, 3 minus 2. So this one gives you 1 over 6 of x times x minus 1 and x minus 2. And now you can verify that Ljxi equal 1 if I equal j, and equal 0 if I different from j. So what does it mean? So suppose you put L0 and you put x0. When you put x0 equals 0, then you have 0 here, 0 here, 0 here, and we'll cancel with the bottom, it gives you 1, okay? And when you put in x1, then x1 is 1, so this one equals 0, and it equals 0. And similarly, you put x2 equal 2, x minus 2 give you 0, and x equal 3 then give you 0. So that's why L0 x0 is 1, and L0 x1, L0 x2, L0 x2 equals 0. So similarly, you can verify, those 3 polynomials or 4 polynomials satisfy this property. Okay, so that's a special property of Lagrange polynomials.